Take it away.
Out. Okay. All right. So, what? No. Do you need to? Now, 1, 2. Okay. Good. Right. Why are we even having this talk? Well, because I'm a geek. I'm a reverser. I'm a hacker, like everybody here. I'm into retro computing, and I'm too curious for my own good. By the way, that's your strongest tool as a researcher, and I like to engage technicians. Every time I will see somebody servicing anything, I'll just look behind their shoulder, play idiot, and ask questions. They will always tell you because no one ever asks them. So that's a lot of information. We're going to base this talk on the attack matrix to show you that the same approach applies to fun projects as well. So we start with recon. I was saying, okay, I want to reverse a payphone, but I need to get some information about it. Let's look for manuals. Guess what? There's a whole website just for payphone manuals, but they're all old models. These are all like coin operated, so there's nothing smart there. So that didn't help, but it was a good start. And I kept my eyes and my camera open. Once I knew I wanted to do this project, every time I saw one of those, I started taking photos. And if you read the abstract, these are mostly no longer in service. This is a device from the 90s, and they've started taking them off the streets, and there are very few that still work in some select places like, hospitals, airports, sometimes prisons, although I think they changed that already. But I kept taking photos because there's a difference between disconnecting it and actually taking it apart, because it's a lot of work, right? So you can see many of those that's in a hotel. And this is actually just 5 months ago in the Israeli airport. This one actually works, right? So, acquisition. How do you get one of those? So the easiest way is just to ask. So I contacted the telco operator. They have a Facebook presence, and I asked for one. They refused. I don't know why, but they said you can't. At first they said you can buy them, and then they said, sorry, you can't have them. Okay, if that doesn't work, then secondary market. I saw on Facebook Marketplace, someone was selling that for roughly, let's say 180 euros, give or take. It's not a small amount, but I really wanted to do the research, so I went and I got it. It looks quite good. It's a good physical shape. So, initial access, how do you get inside? Well, the thing is locked, right? And it's not just a regular lock. If you were outside in the hacking corner, they have some examples of crypto algorithms, and they use like regular keys and stuff. This is a Yale pin-in pin, which means, you can see the pins here, which means inside of each outer pin, there's an inner pin. And it's not trivial to pick that. It just so happens, this all happens back in 2019, that I was about to go to DEF Camp, which is a excellent conference, terrible name, but I still like it. And it just so happens that they have a lockpicking village. And it just so happens that the guy running the lockpicking village is a friend of mine. So I came to him, I showed him the photos, and he gave me a set of pics. So I went back home, and then I started watching YouTube videos because I'm not a lockpicker. I don't really know how to do that. And it's quite complicated. Take a look at this. Do we have audio as well?
And this custom dimple pick that was given to me by a friend. Adding a lot of tension because it is rough inside, so we have to push past that. Click on the outer pin on 1, outer pin on 2, outer pin on 3. Nice click there.
All right, so you get the idea, and this is like one of the best lockpickers in the world, and he has 2 hands, right? So it's difficult. However, it worked. I don't know how. Don't ask me. I did that. Took me less than an hour, and I got it open. You can see the lockpicking set and everything on the table. So you get inside, now it's time to do discovery, what you have around you. So this is the box open. The biggest thing is, of course, the motherboard. That's what we're interested in. You have the earpiece. You have the place where the phone line actually connects. This is a distribution board. It just translates this big cable from the motherboard into the other peripherals. You have the LCD screen, the keyboard, which is just a regular matrix. You have the card reader, which I'm not going to talk about because I didn't get to it yet. And there's a backup battery. That's the thing, right? Now, this is a payphone, so if you kind of try to figure out who's going to be making that, you have a list of possible suspects. Israeli military industries was not one of those suspects. And it turns out that the reason they did that is because they had the technology and that thing needed to be armored against vandalism. So who better than weapons manufacturer? So that's the maker. This is the motherboard when you take the shell off. This is a plastic shell. This used to be the phone number. And this is a better photo. This is quite the device, right? You can already see this is not some coin-operated thing. The top half, right up to the big capacitor, that's an actual computer, which we'll be talking about. The lower half is the part that deals with the signaling of telco. The CPU, right? You want to reverse something, you got to know what the CPU is. This is CDP1086ACE. And that's kind of unique. You don't see that often. The grandfather of that was actually already launched in 1974, the 1802. It was succeeded by 804, 805, and 806. And it was used in spacecraft and space science programs like, what does it say here? The Hubble Space Telescope, because it's very durable to radiation, which is also why I guess the Israeli military industries would have that. Getting the firmware was relatively easy because you can see this. The cover is usually a giveaway for a chip that holds the software, and it's actually a flash AT29C256. If you look at the data sheet, 32 Ks of data, makes sense. And then I read it. Now this is an old device which I just had lying around. This is from 2019. If you want to do it today, you're going to get something better and cheaper. Probably the TL866 or its successors. There's a 52 and 74 or something like that. They look like this. And first thing you do, you get the content out. You look at it to make sure that you do like a sanity check, right? So right off the bat, we see indicative strings. Good English, like there's no any bit changes. And these are all strings that actually relate to phone operation. And if you go to the end, we find the author names, which is kind of cute. That people back in the late 80s, early 90s bothered to put their names in the code. So, of course, what does an Israeli do? Finds them. One of them is no longer living in Israel. He moved to the US. He was very surprised that I found that. He told me a little bit of the history. It started in assembly, then they moved to C. And I couldn't find the other one. Sadly, she passed away just a couple of months ago. Sorry about that, but I didn't know that at the time. Right, so you got inside, usually through the weakest link, and now it's time to do some lateral movement. You want to move to other devices in the network. So, how do you scale up? I hit the jackpot. Somebody put a post on Facebook saying that there was a junkyard in North Tel Aviv where they were throwing these away. Right? You can see the date. This is November 23rd, 2019. So I immediately got into my car. I rushed there. They were being dismantled and dumped. And of course, I felt pity for all the phones lying in the mud. So I said, okay, let's help them get a better house. But here's the problem. They all were still connected to the pole that they used to put them in the street. And in order to take it away from the pole, you have to open it first, because the bolts are on the inside of the chassis, which meant that lockpicking was no longer a viable option if you wanted to do 5, 6, or more. So when the going gets tough, we kind of changed the methodology. A friend gave me a drill. and some of them responded well, some of them not so much. This actually broke the drill. But a few trips later, a little bit of perseverance, and I was able to open my own PSTN network at home. I got additional 12 devices. There are consequences for dumpster diving. I had hardware bugs, as you can see, real bugs. This is a stills photo, but the ants were alive. They were moving on my desk. Right. Resource development. You want to research it. You need to create your own tools. Looking at the CPU, it's very weird. It starts okay. It has like 16 general purpose registers. And it turns out that there's a special register that says which one of the 16 is the instruction pointer. And I'm like, what? Every one of the general purpose registers can serve as the instruction pointer. Okay. And it turns out that if you want to pass an immediate value to a function, you do it in the code. These are the bytes following the call opcode, which is very weird. And of course, because it's weird and no one ever uses that, there was no disassembler module for that. I went to IDA, right? I'm old enough to call it IDA. Some call it IDA now. It has a gazillion processors, but it doesn't have the 1806. And then, of course, the second choice is the Ghidra. Again, a bunch of processors, but no 1806. This is 2019, so some of the options that we have today didn't exist, and I was not going to use Radare because I wanted a UI. I know it's strong enough, but I didn't look at it. Somebody had written like their own disassembler, but that was text mode. I haven't done this disassembly like this since 87 or 89, so I wasn't going to do that. So I said, okay, I have to develop my own CPU module. In IDA, it's more difficult. You got to do actual, development. But in Ghidra, it's just text files. And I'm a reverser. I'm not a developer. I don't like writing code. So I went for that. Now, in order to know how to do that, you read the manual and you read some more manuals because you got to make yourself very acquainted with the CPU. I read some user-generated content. Other people wrote about the CPU. I even found a great presentation from a conference just a few months earlier talking about how you write your own CPU modules for Ghidra. That was very helpful. And Ghidra actually comes with a demo or a sample of a CPU definition. They chose MSP 430. Didn't matter. You have the files. You can see how to do that. So I used it as a template. It tells you how to build everything, right? So I started by mapping all the opcodes. It's a very basic CPU, so the opcode is always 1 byte, so there are 256 options. And then I started writing the definition of the CPU. You start with language definitions, which tells Ghidra how it's going to work. And then you have the architecture definition. You define the registers and the flags and how things work and indianity and everything. And then you write some pseudo instructions, stuff that you're going to be using later, like macros, to repeat operations, because you have to describe complex operations in their language, which is called SLAY. Then you start with defining the simple opcodes, things like move or increment. Those are easy to write, but then you get to the complex opcodes, which require a little piece of code, like you write a function which does things. Just think about, exchange, right? How do you exchange two values? A goes into temp, B goes into A, temp goes into B, right? These are 3 steps to define one opcode. That's just an example. It just so happened that, again, in November, I had to travel to Cancun to give a talk at one of the events by Kaspersky before they were made the bad guys. And I traveled to Cancun, right? That's in the Caribbean. And I was so obsessed with it that I was sitting at the pool writing the code definition for the module. And the first success was actually getting Ghidra to recognize the fact that I had created a module. So now you can see the 1805 here. I started with 1805 because 1806 is only slightly different, and I thought I would make it generic. Doesn't matter. file was actually loaded, and the moment of truth, you start with a binary and disassemble. Boom. Now all the opcodes are working. Now that starts a long cycle of improving the work, because you do some reversing and then you find out there's an error, or you forgot something, or something is not accurate. So you go back and you modify the CPU definition, and then you have to redo most of your work or import it. But in the end, that worked, and then I changed it also to 1806 because I added the new opcodes. Now let's go back to the peculiarities. The thing that defines the IP, which registers the IP, you need to know that, because when you read the code, for example, this is the reset code, the opcodes that says out is going to use a certain register to determine what exactly to do. You need to know that when you reset, the default instruction pointer is the first register, R0, right? So these are things that you need to know and kind of keep a state machine inside your head, or Ghidra. And then the call, I mentioned that you have to put immediate values right after the code. So here's an example. You can see S call, subroutine call, and you can see the values. These two subroutines, you can see my comment on the right after having reversed the function itself. So you can see this function takes 2 words as input, and you can see how they come right after the code. This is very interesting because that means it's the subroutine's responsibility to know to go back not to where the stack pointer shows, but rather X bytes after that. And if you don't do that right, of course, you screw everything out. I am assuming this was done by a compiler, but I don't know. Anyway. And then you start recognizing interesting functions. This one is called erase block. So, good. Next, you load a file. You need to create additional memory areas. Which one is the RAM? The LCD turns out to be memory mapped, so I mapped that as well. And you start to create data types, because as you reverse, you probably know that, you discover structures, way to control data. So functions that, for example, display things to the screen, they accept a structure, which says a bunch of things. So I created a bunch of data types. You can see here, for example, memory copy, for example, will take source, destination, and size. Basic stuff, just like any other code you reverse. But here, the environment that you're working with doesn't give you anything. Sorry about that. You got to start from nothing and create it all on your own. Basic functions is digit. It wants to know whether it's a digit. Is in range, right? I gave it simple names. Who remembers pop count, population count? So pop count measures or counts the number of 1 bits inside a value. This was originally used for setting the parity bit. For some reason, they used it here. Add 2 words. Checksum test. Byte to hex ASCII. Remember that. We're going to be seeing that later. Another thing that I had to run into was the Hebrew strings. Back in the days, again, late 80s, early 90s, there was code pages, and ASCII, the official ASCII is only until 127. Everything other that is no longer the ASCII standard. And then every language would do some mapping. Usually, by the way, if you're old enough, you remember chcp, DOS command, change code page. Usually Hebrew is either at 128, like 80 or E0. Not here. It was a different range altogether. So I had a friend that helped me back then. I wasn't very good at Python. Again, it's like 6 years ago. A friend helped me to create a small script that I could run and then create comments on the entire binary by reading the encoding. So that was very helpful when I was reading the code, because now every string had a comment with its Hebrew name. Now, code execution. At some point, I decided that I want to get this running. I just connected it to 5 volts, and for some reason it worked. But I got a message saying the phone is not usable. This is Hebrew, which is a bummer. Now, I had mapped enough information to be able to look for the code that sends something to the screen and then say, okay, where's the phone is not usable message being printed, which I found. But it was being called from no less than 13 different locations. Now, this is all static reverse engineering. I have no idea of knowing which one of the 13 locations ended up branching into this error message. And that's important because I need to know which one I have to bypass or further investigate. So, just reading the code was not going to be helpful. This project is not about making things simple. It's about learning and just, the principle of things. So I decided to listen to the bus with a logic and try to catch the address of the function and then look back and see which argument was sent. So I used the Soleil logic. Back then I had the 8-bit version, and this is the pinout of the CPU, and I connected it and it all worked, and I collected 7 seconds of data, but I did not find what I was looking for. Now, I don't really know why. Maybe it was maybe I connected the wires wrong, maybe something else. Didn't work. And then in Hebrew we have a saying, if force doesn't work, use more force, which is a way of saying I'm not going to back down. So as I said, this is not about making things simple. So I said, okay, if I can't do that, well, what I can do is patch the code and then send it to the LCD. Of course, because why not? That's the logical thing to do, right? Yeah, I could send my strings to the LCD. What does it require? I needed to hook all 13 locations. I needed to store the current address, resume the original execution, and then overwrite that error function to send whatever I needed to the screen, right? Looks simple. I needed also to find unused memory so I can write my code, like my hooking routine. I needed to figure out which registers I could overwrite as to not destroy everything else. And I needed an assembler because writing that manually would have been a bitch, pardon my French, and I was not going to do that. So that's the mapping of the area. This is the function I wanted to hack. And it's not as cool as ROP Gadget, but it's still living off the land. I was going to use the routines that I had already mapped and use them for writing to the screen, right? That's kind of cool. And I told you before to remember byte to hex ASCII. I found a routine that if I give it a byte, which is the lower or the higher part of the address, it will convert it into an ASCII string. Excellent. So there you go. Now, I did find an assembler. Someone wrote that once because they were reversing or hacking some Nokia phone. This is putting it all together. I wrote it in a text file. I did a lot of prep. And these are the hooks. This is where we convert it to hex, store, and resume execution. You can pause the video later and read that. There were 2 problems with the code. I forgot that this is not a PC. I was not running in RAM, I was running in ROM. So I couldn't just store stuff anywhere that I wanted. And just printing the address was not cool enough. Because again, while we're at it, why not? So we're going to save the string, the whole string somewhere else. And we're going to skip the address assignment and print a nicer text while we're at it. So the final code, here you can see all the hooks. I'm saving the actual number. And this is the coding and going back, and this is where the address will be. And the result address is 4930, which was very cool. And now it was time to go see what that does. If you look at 4930, then you can see that indeed there is some test going on, and then it says long branch if 0, print out of service. So the whole thing actually worked. Persistence, right? How do you keep yourself in the machine that you took over? Well, I started contemplating about replacing the PCB. There was no point in keeping the PCB. They were taking them out of service. The back end was no longer there, so the whole thing was not going to work. But the chassis was nice and the peripherals were working. So let's try to see what we can do with that. This is the LCD. If you're old enough and you played with stuff, you remember the HD 44780. This is the regular Hitachi LCD controller, and there are actually libraries for Arduino. So I tested that, and I saw that I could use an Arduino to write to the screen. I thought maybe to take apart a regular phone that is not sophisticated and just put it inside. And then I said, okay, let's see. I found it on the internet. Somebody created a module for caller ID extraction, which was really cool. So I said, okay, let's combine it all together and build a phone that actually works only with modern electronics. And then life happened. 2020 brought COVID. And other than that, I had this huge project at work. I was doing threat assessment on a Boeing 787, and that's about this much books in English, and I had no time. The project was frozen until last year. I went to Ecoparty in Buenos Aires to give a talk, which is exactly where I'm going next from here, and I met a fellow Israeli researcher. I told her about the project. She said I'd be happy to see some photos because she's also doing some hardware reversing, and I ended up writing a blog post instead because I said, well, I do have a blog. It's about retro computing. It's in Hebrew because there aren't enough resources in Hebrew, but what the hell, let's do that. And that's what it looks like. It says, turns out that a payphone is also a smartphone. Telling you the whole story that I'm telling here. That thing exploded. I completely not expect that. Most of my posts get between 100 and 400 posts. It's okay. I'm not doing it for the likes. I'm doing it for the very small retro computing community in Israel. This one, everybody loved it. And I got calls from some video blogger from the US, and he had me go, and I had it in Hackaday, which is always like an achievement unlock when you do a cool project. So this is now about 5,600 views. It's in Hebrew. You can still go and I use high-level Hebrew, so Google Translate works well. What can we do next? I can continue to research. There's stuff to do. Some of the phones don't work. I never actually got to work on the card reader, which is a complete computer. Maybe I can figure out the protocol and try to talk to the back office because there are still some phones that work. That's probably not going to happen because it's probably not legal. Okay? Or I can just do the modern hardware replacement that I mentioned. Or you can use that for creating CDFs. It's really cool. You can just say, okay, you have to pick up the phone and you're going to get a message and then you have to dial some secret number. Very easy to do because this is all standard hardware. Now, I have a couple more minutes. This was originally created for a conference called Blue Hat IL. It's a Microsoft conference, and it was all about AI. This is not about AI. Not only is this not about AI, this is a talk about a project that I did 5 years ago about a technology from 30 years ago. And still people loved it. Why? Apparently, this is a lot of reversing challenges. Now, I'm 50, so I've been doing this for a while, and for me, it was a challenge, but it wasn't like a big thing. And for others, it is. And why am I telling you that? Because we do things that are not trivial for others. I'm in this area for a very long time. Some of you, not so much. But things that are trivial to you are not trivial to somebody else who's walking in your steps just 1 or 2 years back. Even if you think it's so simple, somebody else doesn't know it yet. They don't understand it yet, and they want to, right? So I encourage all of you to share your knowledge, whether it's on stage here or create your blog. Remember, even if you think it's stupid and trivial, somebody else doesn't know it yet, and you're going to teach them. And it's really cool because this is all about a community. And just like Klaus said, I've been coming here for about a decade. That's a community, and you have a lot to contribute to others. And besides, it's always nice to be on stage and talk to people, especially if you're afraid. Once you get over that, It's really cool. We started late. I don't know how much time I have, but I'm happy to answer questions, if there are any.
We'll win back the time later, hopefully. So, questions? Anyone?
Hello. First, thanks for the presentation. Really interesting. But also, I was wondering, were the resources for this project uploaded on the internet, like, for example, on a GitHub repo?
Yeah, I did. My GitHub has it has the CPU definition, and I think it has the ROM as well. Ping me on Twitter, and I'll make sure later, just in case. But yeah, the intention was to share everything. Yeah.
Okay, thank you.
Anybody else?
If possible, you can also share something that is not Twitter that people can reach you on.
Just my name on Gmail. Really.
That's better.
Yeah, with the dot, without the dot. I hope you all know dots don't matter on Gmail. All right. I bought you some time.
Well, good job. Thank you. Thanks a lot.